All right, y'all, today we are going to talk about implicit differentiation. So 3.2 notes, implicit differentiation. What is an implicitly defined relation? All right, so the first thing we're going to do is write down some examples of implicitly defined functions. So here's our first example, x squared plus y squared equals 1. It's the equation of a circle. That is an implicitly defined relation. What about this one? This is also an example, 3x cubed plus 4x squared y plus xy cubed equals 4. That's implicitly defined. Okay, how about some non-examples really quick? Let's get some non-examples down. This it would not be an example. Y equals the square root of 1 minus x squared. All right, another non-example, y equals 3x cubed plus 4x plus sine of x. These are not implicitly defined relations. All right, so what's the point? What do we notice? Well, we should notice that for implicit relations, we have x and y together, like on the same side of the equal sign. Y is not isolated. So what can we say? We can say that it's not explicit. It is not explicit. So it's the opposite of implicit. It is not explicit. Or the word explicit means clear. It's not clear which variable is independent and which one is dependent. Which one is dependent? Okay, so that's all implicitly defined relations means. We can't tell which variable is independent or dependent because they're not isolated. They're all on the same side. They're kind of all doing their thing together. Okay, so how can we find the derivative? We need to know how to find the derivative of an implicit relation. Here we go. Here are some steps. So I want you to make sure you get down all of these steps, guidelines for implicit differentiation. Go ahead and pause, do what you need to do to write down all of the steps for implicit differentiation. All right, cool. So now we're actually going to do some implicit differentiation. But the first thing we're going to do is kind of compare it to normal differentiation. So we have our regular functions over here on the left. So please get all of these down. You have your normal functions. And then you have your implicit over here on the right. And we're going to take derivatives of each and see how they're a little bit different. So your first step, by the way, said differentiate both sides with respect to x. Well, we don't have two sides of the equal sign, so we're just going to be differentiating the left side. But with respect to x is really important. So let's go ahead and do that for these normal functions. We should know these. So you should be able to fill out these derivatives. The derivative of x equals 1. The derivative of x cubed equals 3x squared. Derivative of tangent equals secant squared x. Okay, cool. Why are we allowed to do this? Why has this been working out for us like the whole class? Like ever since we started doing derivatives? Well, this is why. You're differentiating with respect to x. And your variable in your function is x. All right, so you're taking the derivative with respect to x on each of these, derivative with respect to x, and your function has the variable x. So it works out. Well, on implicitly defined functions, you're taking the derivative with respect to x, but your variable is now y. And you'll notice that that's true for all three of these. Your variable does not match. That's not what we want. So, well, I guess it's not that it's not what we want, but that's not the same thing. We have to differentiate differently. So now we are going to do implicit differentiation. So here we go. We take the derivative with respect to x, and here's how. I'm going to show you how. So you are going to take the derivative of y normally. So act like it's normal. Act like normal. Kind of pretend like it's in x. So what was the derivative of x over here? It was 1. So we'll take the derivative of y, act like it's normal, say 1. But then, because we took the derivative of y with respect to x, we have to multiply by, so we're going to do 1 times dy dx. So act like normal, take the derivative like normal, then multiply by dy dx. And you're going to put this every single time. You're going to put the dy dx, multiply that in every single time to your derivative. So let's try the second one. Act like normal. Pretend that the y is an x. Take the derivative just as you would as if it was an x. We'll take that 3, put it out in front. So we have 3y squared, right? That would be like a normal derivative. But because we took the derivative of y with respect to x, the variables don't match. We have to multiply by dy dx. It's like saying we still need to kind of consider the derivative of y with respect to x, because we still haven't taken that derivative. Okay, and the last one, what is the derivative of cosine? Take the derivative like normal. We have negative sine, sorry, but my variable is y, so negative sine of y. But because with respect to variable, the derivative with respect to x, but it doesn't match the variable in our equation, we're going to multiply by dy dx, the derivative of y with respect to x. Okay, that's how we differentiate implicit relations. Now, let's do like an actual example following those steps from above that we wrote down. Okay, differentiate x plus 3xy minus 2, make sure you get this down, minus 2xy squared equals 2 at 1, 1. All right, the first thing we need to do is differentiate both sides. So I'm going to do this like step by step based on what they were saying. So the first thing we're going to do is take the derivative of both sides, and we're going to take that derivative with respect to x. So it's kind of like we're saying do dx of the whole thing. Okay, of both sides. Let's go ahead and do that. So here's the derivative. The derivative of x is 1, right? Now, this is kind of weird. Check this out. We have two functions here. We have 3x and we have y. What's the operation happening in between these two functions? Multiplication. So we have to do a product rule. So I'm going to do a product rule with this one. So here we go. We have 1 plus. I'm going to put parentheses just to represent that I'm doing a product rule so that you can see it. But technically you don't have to put parentheses. All right, product rule. Derivative of the first times the second. So derivative of the first is, here, I'll label them for y'all. First, second. Okay, derivative of the first times the second. We have 3 times, leave the second the same. Plus, product rule says plus, derivative of the second. What is the derivative of y? Remember, it's 1. But because we differentiated with respect to x, we have to multiply by dy dx. Derivative of second times the first. Cool, that was the product rule piece. Now we have minus, take the derivative of negative 2y squared with respect to x, we get 4y. Because it was with respect to x, we have to multiply by dy dx. Equals, take the derivative of 2. What's the derivative of 2? 0. It's a constant. All right, cool. So the first step we are done with step 1. That's this pink derivative. Okay, step 2 said isolate dy dx. So step 2, we need to get the dy dx on the same side of the equal sign. And we may have to factor out a dy dx if necessary. So the first thing I'm going to do is erase, first thing I'm going to do is erase the parentheses. So 1 plus 3y, and the like dots to represent multiplication and stuff. I'm just going to clean this up a little bit. So I'm going to put the 3x in front of the dy dx here. I like to have that in front. Then we have minus 4y dy dx equals 0. All right, first step to isolating dy dx, you need to get everything else on the other side. So anything that doesn't have dy dx, move it. Move it to the other side of the equal sign. So we're going to do minus 1 and minus 3y on both sides. And then we have 3x dy dx minus 4y dy dx equals negative 1 minus 3y. Sweet. Here's where we need to factor out a GCF. Our GCF is dy dx right here. That's the greatest common factor. So we're going to pull it out in front. So we get dy dx. And when we factor that, we have left on the inside, we get 3x minus 4y equals negative 1 minus 3y. Sweet. And then just so you know, I should have written this down. Step 2 is isolate dy dx. Step 1, I'm going to go back really quick. Step 1 was take derivative of both sides with respect to x. With respect to, you can write WRT with respect to x. Okay, cool. So let's continue isolating dy dx. We just need to divide now. We just need to divide the 3x minus 4y to the other side because this is multiplication. So we get dy dx equals negative 1 minus 3y divided by 3x minus 4y. Okay, sweet. Now that we have that, the final step is to plug in your point if you have one. So really quick, we have to notice we do have a point. We have 1, 1. And let's make sure we remember that means x equals 1 and y equals 1. So the last thing we're going to do is plug that point in. So we'll say plug in point 1, 1. So dy dx at the point 1, 1 equals, I'm going to plug 1 in for x and 1 in for y. So we have minus 1, minus 3, parentheses, plug in 1 for y, and then we have 3, plug in 1 for x, minus 4, plug in 1 for y. We do not have to simplify. So our final answer is right here. Boom, done.